So this is possibly the most intact woolen mill anywhere in North America. This is the 1859 Watkins Mill here in Missouri. I'm Darren, and this is the Industrial Revolution. Let's go take a look inside. Wait a second, we can't just go into a woolen mill without some wool. Everyone will wonder why we're there. Let's stop off at Greenfield Village in Dearborn, Michigan to get some. Here you can see the traditional way of shearing sheep up until the 1900s, when electric shearing machines eventually took over. Modern domesticated sheep typically get sheared once a year in the spring, as soon as it's warm enough that they don't need their warm, heavy coat anymore. They don't shed the wool on their own, so they really do need to be sheared, or they'd be very, very unhappy on hot summer days. Your goal in shearing is to get as close to the skin as possible, to get the longest fibers, and also to remove the entire fleece in one piece. You're paid by the quality of the fleece, which is how many pieces it's in, how long the fibers are, and how clean it is. There's about 6 fleeces in this pile. If they look dirty, well, that's because sheep don't tend to have the greatest personal hygiene. Believe it or not, the sheep here at Greenfield Village are actually pretty clean compared to average sheep. Now that we have some wool, let's head back to Watkins Woolen Mill State Park in Lawson, Missouri, to follow it through the production process. So first we have to clean up the wool, and that's done in the shed out back in these 2 large iron cauldrons. These cauldrons were filled with water from the adjacent well. Lye was added, made from wood ash. Then the raw fleeces were soaked and gently agitated to remove many of the contaminants from the wool. For good or bad, it also removed the lanolin. Today, that lanolin can sometimes bring in more money than the wool itself, but here at Watkins Mill, it was broken down and discarded. After washing, you have somewhat cleaner, very wet, very heavy fleeces. These were then spread out on this large deck on the south side of the mill to dry. While they're drying, let's talk a bit about the history of the mill. In 1839, Waltus L. Watkins moved to Missouri and created the Bethany Plantation. The plantation grew gradually over the next couple decades before, in 1859, he built the mill here to produce wool yarn and cloth for sale in his store, which was located at the front of the mill. While some of the mill workers were essentially unskilled labor, many, including those working the carding, spinning, and weaving equipment, were actually considered to be skilled labor. They were housed on site, including in the old octagonal school, which closed down in 1856. It's pretty sunny out here today, and pretty warm, so the wool should be just about dry. Let's go back inside and continue production. From here on out, we'll need power, and lots of it. In the shed out back, next to the well and washing cauldrons, there's this 65 horsepower steam engine. Details on this engine are a little vague, since the history on the place was written by someone who knows woolen mills, but maybe isn't quite so good at steam engines. Still, let's take a look. Steam was provided by this multi-fluid boiler, which was, reportedly, salvaged from a steamboat. Steamboats on the Missouri River tended to have a very short life, averaging only around 5 years or so. So assuming it somehow didn't explode when the riverboat sank, that'd be a good source of steam. You can see that the fire was built under the boiler at this end, with the flue gases then traversing under the boiler itself all the way to the far end, heating the water on the way. At the far end, the hot gases go up and enter the multiple flues running through the length of the boiler, heating the water even further. Check out my boiler video for more info on how boilers work. Looking at the flues today, we can see that 4 are still open, and it appears that it had a 5th flue at one point, and that one was capped, likely due to a leak. That was a common practice to manage leaks. You lost some power, but you were able to keep working. The boiler is reported to have operated at 100 psi, but to me that actually seems kind of high. They later cut the steam pressure, maybe when that one flue pipe developed a leak, to try to extend the life of the engine. Keep that in mind. It didn't fail explosively the first time when that flue leak developed, but that wasn't the last failure for this boiler. it'll become really important to the mill later on. Looking across the boiler, we see the water glass. The water glass ensures that the water level in the boiler doesn't go too low, and also that you have enough room for steam buildup on top. We can also see the high-tech pressure safety valve. Yes, that actually is just a metal plate laying across an opening, and it's held down by a weight hanging on the end of that long bar. You can adjust the maximum pressure just by changing the weight hanging there. And if you didn't notice, while there is a whistle, there's actually no pressure gauge on this boiler. So the simple overpressure valve was the only thing that kept this boiler from exploding. The engine itself is pretty basic. It's just a single piston with a crank going to this huge iron flywheel. That flywheel shares an axle with another large wheel inside called the master pulley, where it then connects via leather belts to every machine in the entire mill, providing all of the power used here. But now that we have power, let's get back to the wool. First, the washed wool is fed into this machine called a willower. Its job is to knock the bigger pieces of debris off the wool. Before this machine was invented, people would sometimes beat the wool with willow branches to try to get the bigger pieces of stuff, which includes twigs, leaves, and the rather euphemistically named biologic materials, out of the wool. From the willower, it then goes on to the much bigger picker. In the picker, these scary, high-speed spinning wheels with sharp wires and big steel teeth rip into the wool, separating out the smaller debris and leaving just nice, clean wool kicked out the back. Here at Watkins Mill, the willowing and picking were done with two separate machines. In many places, it was actually done with just one. Even with the shield lowered in place over the picker, I still don't think I'd want to be hand-feeding wool into this machine. Okay, now we've got the wool clean, but there's a problem. Remember how, when the wool was washed, all the lanolin was removed? Unfortunately, we just can't work with it like that. The wool is just too dry and brittle. We need to put some oil back into it, or it's not going to work on the spinning machines. So now you take this nice, clean white wool that we've just been working on for hours, and you throw it all on the floor up against that nasty black stained wall. Go get some melted lard, which is rendered pig fat taken from the plantation's own pigs, and pour it all over this nice clean wool, and then we'll toss it with a big metal pitchfork until it's all covered nice and even with just the right amount of lard. You can always add a bit more lard or a bit more wool until it feels just right. And you carry it upstairs to the carding machines. Before you can do anything more with the wool, you need to get all the fibers lined up nice and straight. This is the job of the carding machines. Watkins Mill runs all the wool through 3 separate carding machines, and they have several sets of 3 here. Older carding mills would typically just have one machine to produce bats, or flat mats of wool, and a second to produce roving, or long rope-like wool. They didn't use 3 machines like this. So what's going on? Well, it's actually all about mass production. So first, you take this fresh, lard-covered wool, and you run it through the first carding machine called the breaker. The breaker, like all carding machines, uses high-speed rotating drums covered with this wire-coated material, which acts like brushes, to roughly line up the fibers. In a way, it works just like brushing your hair, but with a bunch of high-speed steel brushes. The breaker outputs the wool into mats, which are called bats. These wide bats are great for things like using in quilt insulation, but it's just the first of 3 carding operations here. Next, you take several of these bats, stacked on top of each other, and feed them into the second machine called the intermediate. This machine, like the first, uses the same spiky wires on fast-spinning drums to combine the wool from the different bats, straightening the fibers together, and finally outputting a more uniform bat, ready for the third machine, which is called the condenser or the finisher. So once again, we stack up those now more consistent bats from the intermediate carding machine, and feed it into the final machine. So the finisher carding machine once again combs and straightens the fibers, combining the bats, and creating a now very smooth, very even, very consistent output. But instead of creating another bat, this machine actually produced what's called roving, which looks like and sounds like a soft, fluffy rope, perfect for moving into the next step. These are the spinning jacks here at Watkins Mill, also called spinning frames, spinning mules, and probably plenty of other names. If you know other names, let me know in the comments. These were actually 1820s technology, so they were a bit obsolete when they were installed here, but they're still pretty hard to understand. To see how they work, let's go back just a bit further in time to the manual spinning wheels, which work almost exactly the same way, but with only one spindle. Here you see he's holding the carded wool in his left hand and turning the spinning wheel with his right hand. The spinning wheel is connected by a belt, which very quickly spins the spindle itself. Yes, this is the spinning wheel spindle that Snow White pricked her finger on. As the spindle twists and you slowly back away from the spindle, you also slowly allow it to pull the wool from your hand. As the wool is pulled away from your hand, the spinning spindle twists it into yarn or thread. You adjust how thick or tight the yarn or thread is by how fast or slow you move away from it, and also how much you let slip through your fingers. Your goal is for it to be as even as possible. Now it's twisting the thread, but if you look, you can see that the thread is actually popping over the tip of the spindle over and over instead of winding onto it. That's important since that's actually how it twists the yarn. The tip of the spindle is never sharp, and it actually can't be. It'd instantly slice right through the thread if it were sharp. I'm afraid that does mean that you can't really prick your finger on it, and since that's a major part of the Snow White story, well, sorry if I just ruined your childhood. Anyway, now that we're a ways back, it's time to wind up the thread. With the manual wheel, you back the wheel just a bit to let the yarn trailing onto the end of the spindle come off. Then you move over and spin the wheel forward again, spinning the yarn onto the spindle and returning your hand towards the spindle to start again. With the spinning wheel, we had one person working with one spinner, and that's how it was done up until the Industrial Revolution, when these much larger mills came into operation. Here you can see there's a lot more. There's 18 spindles per each section and 12 sections per machine. With two machines here, that's 432 spindles with just two skilled operators. The way it works is just like the spinning wheel, but a lot more and a lot faster. The roving, which, remember, was carded 3 times to make it very uniform, is wrapped around the horizontal bar at the back. The metal spindles are all spun at high speed as the frame moves very slowly forward. Just like on the spinning wheel, the wool is pulled from the roving and twisted. The spinning speed, and how fast you move the frame forward, controls the exact qualities of the thread or yarn that you get. When you reach the end of the frame, it drops the thread down onto the wooden bobbin, which is loaded onto the metal spindle. The operator then turns the large wheel in the center of the frame to guide it back, spinning the newly formed thread onto the bobbin. When it reaches the back, it moves the thread back up to the spindle, and it starts forward again. Eventually, you're either out of roving or your bobbin's full, hopefully both at the same time. Then, unless you're selling thread, it's time to move on to the twister. This is the twister, or twisting machine, or twister frame. It takes the bobbins from the spinning jack and twists multiple threads together into a larger yarn or thread. Here at Watkins Mill, they have 2 of what they claim are only 4 surviving twisting machines from this era. From the twister, the yarn feeds directly into this large wheel called the skein wheel. If you're using it in-house, you'd probably just go until you've gone through the entire bobbin. But if you're selling yarn, you'd stop at the desired length, cut it, and using the skeiner, tie the yarn into a loose knot ready for sale. If you're planning to weave it here, you'd instead move to the warp dresser. This machine is to help set up the looms for operation. Loading spools of thread from the spinning machine, The thread is fed up through the frame and connected to the wheel at the back. You spin as much thread as you need to onto that wheel, depending on how much fabric you want to make, and you cut all the threads at that length. You even have a gauge to tell just how much you've wound. These threads are the warp threads, which run from the back to the front of the loom, the full length of the fabric. There's a good chance that they added starch, called sizing, to the threads at this point to help stiffen and protect the threads from the high tension and abuse of the upcoming weaving process. Now let's move over to the loom to see how it all comes together. So this video is made possible thanks to the generosity of people helping out here on YouTube with super thanks, or through memberships at patreon.com/industrialrevolution, or by clicking the join button here. If you're able to help out, I appreciate it. If not, fully understand. In any case, let's get back to the video. The threads from the warp dresser are brought over to the loom and loaded up, with the threads going through the frames for weaving. Frames are alternately lifted and lowered to control the patterns. A heavy block, called the shuttle, is automatically shot at high speed back and forth between the raised and lowered threads. It pulls the weft thread, which is the thread running side to side through the fabric on the loom. Each time it goes through, the weft is tamped down into place, then the frames are raised or lowered for the next row. There's a lot to the weaving process and a lot of technological improvements there, but since looms are relatively common, and all the other stuff here at Watkins Mill isn't, let's move on to the next step. I'll do a separate video on weaving another day. When the fabric comes off the loom, it's coarse, like burlap, with an open weave. To soften it, you first feed it into this rotary fulling mill. You'd load this up with soap and boiling water, and with your freshly woven fabric. The fabric then runs between the horizontal drums and under the vertical cylinders, which pound up and down, until it's compacted and softened into something you'd be much happier to wear. Before mechanical fulling mills were invented, they did still have to use a fulling process for wool fabrics, but it wasn't quite so clean. Large vats were filled with stale human urine collected from around town. Not a job I'd want, but not the worst. The newly woven fabric was then soaked in these vats, and, an even less desirable job, people jumped in with bare feet and legs and stomped around in these vats for hours, accomplishing the same thing as the newer fulling mills. Regardless of the technique, though, once fulled, if you want something softer still, you can move on to the gigging mill. To soften the fabric further, say for a nice soft blanket, you'd run it through this gigging mill. It uses racks of natural teasel heads. The teasel heads, which come straight from plants, are covered with short, sharp spines that are run against the fabric, pulling up individual fibers and giving a nice, soft, fleece-like feel. Teasel heads were used instead of the wires like those on carding machines, because if the wire caught, the fabric would rip, but if the teasel head gets caught, the teasel spine just breaks loose. No big deal. If the fabric gets too soft and fluffy, then you might want to shear some off. To do that, you'd use this rotary shearer. You'd adjust the height of the blade, then just run through this shearer to get just exactly the right thickness and fluffiness to your fabric by cutting the extra fluff off the top. Now you're all done. You can just send your finished fabric out front to the store. So you might think it was the end of slavery and the end of cheap labor here at Watkins Mill that caused it to shut down. But that's not really the case. It certainly didn't help. But the mill workers here were considered to be skilled workers, so these were not enslaved people here. What really did it, production began to fall off in about 1886 or so, and that was mostly because of things like railroads and steamboats and canals. It became much cheaper to transport goods and materials all over the country, all over the world, and as a result, well, people did. This is a good-sized mill, but at the same time, it's not an absolutely huge mill.
there were giant mills, like 10 times or more the size of this one, that were producing far greater quantities of materials far cheaper. And they were able to then ship finished clothing all over. And there just wasn't so much need for this anymore. Production waned until finally in 1898, the mill here finally shut down. Partly the market had been falling for years. Partly the boiler actually failed. So they had to make a decision. They either put in a new boiler or they simply shut down. And at that point they decided it just wasn't worth the cost of the boiler. So they shut down the mill. Despite the fact that this mill did shut down in 1898, at that point they just closed it up. And the reason that it's still here, it stayed just closed up until 1964. And in 1964, it became a state park, and when they opened the doors, they found everything still intact. And that's why we still have it today. And that's why Watkins Mill here, this is the Industrial Revolution. Hey, thanks for watching. Hope you enjoyed it. If you'd help out the channel, like, share, subscribe, and comment. I love reading the comments. I usually respond to them pretty quick. Also, if you want to see some more of my mill videos, I have a playlist over here full of mill videos, or the one up here that YouTube thinks you'd really enjoy watching next. Again, thanks for watching, and I'll see you next time.